You'll notice that some equations and formulas have fractions within them, and today I'm going to show you how to clear fractions from an equation. We're going to use the least common denominator, and that can be used to clear fractions from the equation. The LCD can be found by factoring each denominator completely. So we're going to use prime factors in order to work through this technique. Once each denominator is completely factored into a product of prime factors, the LCD will be composed by looking at each factor and taking the highest power within all the denominators and finding that product. In other words, it's the product of each of the unique factors to their highest power. So we're going to work with a few sets of numbers here and find the LCD for the following numbers. We'll start with 8, 12, and 24. What we're looking for are factors of 8 besides 1 and 8. So since 8 is an even number, I could break that down as 2 times 4. 2 is a prime number already because it only has factors of itself and 1, but 4 could be broken down again as 2 times 2. So the factors of 8 would be 2 times 2 times 2. Another way to write that is using exponent form. So the factor of 2 is multiplied by itself 3 times. That becomes 2 cubed. Now we'll go through the same technique using 12. So besides 1 and 12, you might think of 2 times 6. 2 is prime, but 6 has other factors. That would be 2 times 3. Since 2, 2, and 3 are all prime numbers, we've completely factored 12 using primes only. But you'll notice that 2 is written twice, so in exponent form, we would have 2 squared multiplied by 3. And now we can break down 24. It doesn't matter if you're choosing 2 times 12 or 3 times 8 or 4 times 6. Once each factor is broken down to its prime numbers, we will all end up with the same string of prime numbers. So I'll just keep going with 2 times something, in this case 2 times 12. 2 is already prime. 12 could be broken down again as 2 times 6. 6 is 2 times 3. And now the factors that I'm left with are prime numbers. So I can see that 2 is a factor showing 3 times. So 2 is cubed multiplied by 3. So when I am composing my LCD, I'm looking at factors of 2, factors of 2 and 3, factors of 2 and 3. So the unique factors are 2 times 3. Now I need to consider what power each of these factors is raised to. I have 2 to the power of 3 compared with 2 to the power of 2 compared with 2 to the power of 3. So starting with our factor of 2, I can see that power of 3 is the highest power for that factor. So I need to include the highest power when I'm composing my LCD. Then compare all your factors of 3. I don't have a factor of 3 for the first number. I have 3 to the power of 1, and here I have 3 to the power of 1. So 3 to the power of 1 is my highest factor for the factor. So 3 to the power of 1 is the highest amount needed for the factor of 3. 3 to the power of 1. So the last step is to multiply. So 2 cubed means 2 times 2 times 2, which is 8. So 8 times 3 will give us 24. 24 is our lowest common denominator. Next, we're using 2, 12, and 18. So if you find it difficult to track your way through these factor trees looking for all those 2's and 3's, I'm going to show another technique that you might like, and I call it the factor ladder. So I'm going to consider factors of 2. Well, 2 already is prime, so I don't need to do anything else with 2. Moving on to 12. I'm going to make what looks like an upside down division, and I want to divide 12, or think of a factor of 12 that is a prime number, such as 2. So 12 divided by 2 will leave me 6. And now I'm going to divide 6 by another prime number. So you could choose to divide it by 2 or divide it by 3. So I'll just continue using 2. 6 divided by 2 leaves me 3. Once again, I'm going to divide 3 by a prime number. So the only prime number possible to divide 3 would be 3. That leaves us 1. When you end up with 1, you know you are done factoring. So this is a nice way to collect your factors. 2 times 2, that would be 2 squared. My other factor is 3. So 2 squared times 3 should get us back to the original factor of 12. And using the similar technique here with 18, I could divide by 3, that's a prime number. 18 divided by 3 would leave us 6. 6 divided by a prime number, you could choose 2 or 3. So if I choose 2, 6 divided by 2 leaves us 3. Keep dividing by primes until you are left with 1. So 3 could only be divided by 3. That leaves 1. So notice I have a pair of 3's and I have 2. In order, I would write 2 times 3 to the factor of 2. So to build or compose our LCD, I have factors of 2, 2, 2. So 2 is a unique factor. And I have some 3's. So again, 2 times 3 is where we're starting, but now we need to consider the exponents. 2 to the power of 1, 2 to the power of 2, 2 to the power of 1. So 2 squared, or 2 to the power of 2, is the highest power of 2. So we need to represent that highest power. Then compare all your 3's. 3 to the power of 1, 3 to the power of 2. 2 is the higher power, so we need to include the higher power. 2 squared makes 4. 3 squared makes 9. So 4 times 9 is going to give us 36 for our lowest common denominator. So now we can see how can we use this technique of creating an LCD to clear fractions from an equation or from a formula. So we have the problem 1/6 x plus 2/3 y is equal to 4. We notice we have fractions. One denominator is 6, the other denominator is 3. 3 already is a prime number, so all we need to do is break down 6 into prime factors. That would become 2 times 3. So to build our lowest common denominator, I can see that I have a factor of 2. I have a factor of 3. Here is also a factor of 3. Both factors of 3 are raised to power of 1. 2 is also raised to the power of 1. So I already have the highest power represented here. 2 times 3 would give us a lowest common denominator of 6. So I'm going to use 6 and multiply all terms in the equation by 6. So I'm taking 6 multiplied by 1/6 x plus 6 times our next fraction, 2/3 y, and that is equal to 6 times 4. So this is called the multiplication property of equality because every term is multiplied by exactly the same amount, so we're making the equation 6 times larger than the original. 6 is used because 6 is the lowest common denominator. So you can see that when you multiply 6 times 1/6, 6 is reducing from the problem, and we're left with x. No fraction is used there. In the next term, we have addition, and we have 6 multiplied by 2/3 y. You might notice that you can write 6 as the rational number, 6 over 1, and that might help your eye to track this a little easier. And 6 reduces with our denominator of 3. That makes exactly 2. So there's no fraction remaining. We have 2 times y, which is positive 4y. And last, there are no fractions. It's just 6 times 4, or 24. Now the directions are asking us to solve the following equation for y. And we have both variables, x and y, on the same side of the equation. So that means the term with y is going to remain where it is, but we need to move positive x. So the way we would move a positive x is to subtract x from each side of our equation. That leaves us 4y now equals negative x plus 24. And the last thing to do is to eliminate the multiplication of this coefficient 4, because 4y implies 4 is multiplied by y. So the opposite of multiplying by 4 would be division of 4. So if this term is divided by 4, all of the terms need to be divided by 4. 4/4 will reduce, leaving us y. Negative x, in other words, negative 1x divided by 4 would mean negative 1/4 x. And if it's possible to reduce fractions, we will do that. 24 divided by 4, that's exactly 6. So instead of writing plus 24/4, that's the same as adding 6. So our new equation solved for y is y equals negative 1/4 x plus 6. So when you're trying to clear fractions from equations, create a lowest common denominator first, and then multiply every term in the equation by that lowest common denominator.